Okay, hi everyone. Here we are again with our online learning, but that's okay, we can do this. Now, for those of you who find yourself at home without your textbook, I've posted a copy of Chapter 12 on Compass for you. So you can access the Chapter 12 textbook from Compass, so you will be able to get on and get the work done for Chapter 12. Alright, now, don't panic because I found myself without my textbook or my laptop or really anything. I literally walked out the door with my handbag. So, we're all just making do and we're doing the very best we can. See, I've got a new book and I've had to create new notes because, of course, the book with all my class notes in it would be at school. But that's all right as well. Okay, we're looking at exercise 12B today. And that's all about using matrices to solve simultaneous equations. If you stop and think about simultaneous equations, when we solve simultaneous equations, we're looking for the point where one line crosses the other. And that's the answer to our simultaneous equation. So when we do simultaneous equations, that's what we're looking for. We're looking for the point where the two lines cross. We can use matrices to help us out here. So, say we have these two equations here. 4x plus 2y equals 5 and 3x plus 2y equals 2. And we want to determine what x and y equal. In such a simple example, doing it algebraically would just be as quick. But you have to remember, matrices allows us to find for more than two letters. We could find for 3 or 4 or 5 or 6 or 7. And doing that algebraically takes a really long time. So being able to do it like this in the matrix format can be really helpful, particularly when you have more than two unknowns. Basically what you do is you're going to take your equations and you're going to put them into three individual matrices. The first matrix is the one we call matrix A, and it's the number out the front that's multiplying the letters. That's what you're going to put into that matrix. So in the first line you can see I've got 4x, well I've put 4 down here. I've got 2y and I've put the 2 here. In the second row I've got 3x and 2y, so I've put the 3 here and the 2 there. That's what goes into matrix A. The next matrix is the one we call matrix X, and that's where we put the letters that we want to find the answers to. So in this equation, the two letters that we have are x and y, so we put x and y. And it's really important that you put them in the same order that they're written in. So here, x comes first in the equation followed by y. If you get a pair of equations and they're not in the same order, say the x and y are reversed, you may find you need to rearrange the equations so that your letters match up. They must all be in the same order. So if you find that situation, just rearrange your equations until you can get them into the correct order. Alright, the last one, we call this matrix C, and that's basically the answers to the equations. So the first equation equal 5 and the second equation equal 2, so I've put 5 and 2 into the final matrix. Now that I have my three matrices, I can solve. Now on the CAS this is pretty simple. So the x and y is going to be equal to the inverse of A. That's why we did inverses yesterday. So it's going to be equal to the inverse of A multiplied by C. Alright, in the CAS calculator, the inverse of A is 1 minus 1 minus 1.5 and 2. Okay, so x is going to equal the inverse of A multiplied by C, which was the answers. We just do this on the CAS calculator. You can do this out by hand. This is a simple enough one for you to do by hand. But we do it on the CAS calculator and we get that x and y are equal to 3 and minus 3.5. Of course, this is just my working out, so I would not leave that as my answer. I, of course, would say x is equal to 3 and y equals minus 3.5. Because, of course, I want full marks for the question. This is just your working out. Remember that. There are points for working out and there are points for putting your final answer in. So don't forget that step. Now, you can use this system so long as the determinant for the matrices does not equal 0. Now remember what I said about why we solve for simultaneous equations? Because we're finding the point where the two lines cross. There are two situations in which the lines are never going to cross. That would be parallel lines, and your determinant would be 0. So if you worked out the determinant and the determinant is 0, it means one of two things. You either have parallel lines, therefore the lines are never going to cross. So there's no intersection point. And we call these inconsistent equations. That's the proper name for them. They are inconsistent equations, or more commonly referred to as parallel lines. The second reason are the equations are dependent. And this just means the equation is for exactly the same line. Therefore, there's not one spot where they overlap. They overlap in lots and lots and lots of spots because the lines sit on top of each other. So we say that there are no unique solutions in the case of equations that are dependent. They are equations for the exact same line. Okay, that should actually give you enough information to be able to work through this exercise. If you've got any questions, ask me in the WebEx session. I'll be there ready to answer any questions that you have. Alright guys, see you later.